Hey students, this is the spiral review for spiral 0.2, our second spiral of just review topics. Functions in quadratics is going to be graded this time, so let's dive in. So we're trying to find g of f of 3. That means we're going to find f of 3 first, which is going to be 3 times 3 plus 5, which is 14. G of 14 is going to be 2 minus 14 squared. 2 minus 196 is going to be negative 194. For number 2, we're given h of x as this function. We've got to find h of x plus c minus h of x. That means we're going to plug x plus c in for our original x. So where we had x's, I'm going to write x plus c. I'm going to do some distribution. We know that x plus c quantity squared really means x plus c multiplied by x plus c. So that's going to give us x squared plus xc plus xc, otherwise known as 2xc, plus c squared. And we got plus 5c, 5x plus 5c, and minus 5. All right, so from this, I want to subtract my original function. I'm going to do this as kind of stacked on top of each other, because what I'd like us to notice is that we've got an x squared, we've got a 5x, and we've got a minus 5. So all of these pieces are in that h of x plus c, which means that they're going to cancel out, leaving us with 2xc plus c squared. Those cancel, plus 5c. And my minus 5's cancel as well. All right, so now we're going to do some factoring stuff. I'm going to start by bringing everything onto the same side. 15x squared minus 37x plus 20 is equal to 0. And we're trying to find things that multiply to 300 and add up to negative 37. That's not as bad a number as I thought it was, so I'm actually going to just dive straight into this. Things that multiply to 300, that's going to be 1 times negative 300, 2 times negative 150, 3 times negative 100, 4 times negative 75, 5 times negative 60. We're still not really getting close to negative 37, although we're starting to. Then we've got 6 times negative 50, 7 doesn't work, 8 doesn't work, 9 does not work, 10 times negative 30, that's going to give us negative 20. And the good news, bad news is that I reached a point where I've gone past that value, and that's the bad news. The good news is that for whatever reason, I decided only one of these had to be negative, so we're actually dealing with both of these values being negative. So we're still at negative 40, so we can keep going here. Okay, so that's 11, nope, 12 will work, so that's negative 12 and negative 25. And hey, those add up to negative 37. That wasn't quite as bad as we thought it would be. So let's do this out with grouping. We've got 15x squared minus 12x minus 25x plus 20 is equal to 0. I can take a 3x out of the first two, and that leaves me with a 5x and a minus 4. I can take a minus 5 out of the next two, and I get a 5x and a minus 4. So we get 5x minus 4, and we've got 3x minus 5. That gives us 5x minus 4 is equal to 0. Because we're solving this, we have to go further and get 4/5 is equal to x. For the other one, we got 3x minus 5 is equal to 0. That gives us x equals 5/3. For the next one, we've got this really potentially ugly thing. And by that, I mean that a times c is going to be equal to, oh, I don't know, 1,680. Ugh. But we have some other tools that might help us with this. One of the ways that we can kind of work through this is to think about these in terms of their pieces and break those things down. So instead of starting from the outside ends, this might start from the middle. So we've got 42 times negative 40. Just starting literally from that and adding those up, we get 2 as an answer, which is pretty darn close to 13. Okay, so this is like 6 times 7, and this would be like 8 times 5. What if I shifted those things around and did like 7 times 5? So I'm just going to write these up here. 7 times 5 would give us 35, and 8 times 6 would be 48. To be honest, I just guessed those two by switching those numbers around and trying to keep them about the same, but that's going to be what we need for an answer, because when I add those together, that gets me 13. This is a calculator active spiral, so you will be able to use a calculator to figure out exactly where those things are, so I'm not really worried about that. This is really a strategy if you don't have a calculator, like I currently don't. So 42x squared plus 48x minus 35x minus 40 is equal to 0. For the first two, I can take a 6x out, and when I do that, we're left with 7x plus 8. And for the next two, I can take a minus 5 out, and when we do that, we're left with a 7x plus 8. That gives me 7x plus 8 equals 0. Sorry, I didn't fully factor. 7x plus 8 and 6x minus 5 are my two factors. That 7x plus 8 equals 0 gets me x equals negative 8 sevenths. And 6x minus 5 equals 0 gives me x equals positive 5 sixths. Those are our two solutions. Now on to trigonometry. In all these, we're doing exactly the same thing, which is we're going to get the trig part by itself, untrigify it, and then get our equation solved if we need to go further. So I'm going to minus 3 to both sides and then divide by 2. When I do that, I've got 1 is equal to cosecant of theta plus 5 pi over 4. Okay, I know that 1 equals cosecant is kind of a nice thing, because we also know that sine of theta is equal to 1 over cosecant of theta. So I can do the reciprocal of both sides, and it really doesn't change much in terms of what our equation looks like, which is really a beautiful thing. Okay, so I'm looking for sine values of 1. So that's where my y value is equal to 1. That only happens at the very top of my unit circle. So we know that this angle is going to be pi over 2. Okay, that gets us to our next stage here, that if this angle on the inside has to be pi over 2, theta plus 5 pi over 4 must be equal to pi over 2. That means that theta is going to be, I'm going to move the 5 pi over 4 to the other side, pi over 2 minus 5 pi over 4. And when I do that, that's really 2 pi over 4 minus 5 pi over 4. We end up getting negative 3 pi over 4, which is a problem. It's a problem because that's not within our domain here. So what we have to do is take that, negative 3 pi over 4, and we have to go around an extra time around the circle to get us 5 pi over 4 as our answer. For the next one, we're going to start the same way. I've got all kinds of stuff going on here. I noticed that I've got a couple things that have fractions, so to deal with that, I might multiply this entire equation by 5. So if I've got 5, 2/5 times 5 is plus 2. Cosine of all this stuff. And on the other side, stop too soon. There we go. That cancels out the 5 there, so we've got 5 plus root 2. Got a 5 on both sides. We could divide both sides by 2, and we get cosine of theta plus 11 pi over 6 is equal to root 2 over 2. That's an x value for cosine. And root 2 over 2 is going to happen at these two positive angles. All right, so that's going to be pi over 4. And going around to here is going to be 7 pi over 4. That's my inside of my parentheses. So we've got theta plus 11 pi over 6 is equal to pi over 4. And we're going to have theta is, theta plus 11 pi over 6 is going to be 7 pi over 4. Getting theta by itself, we've got pi over 4s and pi's over 6. Those are going to be pi over 12s. So 3 twelfths minus 22 twelfths would be negative 19 pi over 12. We need the positive thing, so we're going to add 2 pi to that. And when we do that, we get 5 pi over 12. For the other one, we've got 7 pi over 4 minus 11 pi over 6. That's going to allow us to think in twelfths again. So 7 times 3, 21 twelfths minus 22 twelfths. That would end up being negative 1 pi over 12. Adding 2 pi to that, we end up getting 23 pi over 12 as our answer. Gross fractions in that, but those problems are not so scary. You need to get the trig stuff by itself. You need to figure out what angle we're talking about and then deal with the stuff on the inside. It looks to me like number 7 is going to be pretty similar, so let's take a look. I'm going to do the same thing and multiply everything by 5. It's going to be minus 15 minus 2 sine stuff is equal to negative 15 plus root 2. This is a remarkably similar problem. In fact, I'd call this a disturbingly similar problem to the last one that we just did. And when we get sine of theta plus 5 pi over 6 by itself, it's going to be negative root 2 over 2. All right, unit circle time. Those are our 2 pi over 4s that are below the x-axis because sine is all about the y values. So we've got 5 pi over 4. So theta plus 5 pi over 6 is equal to 5 pi over 4. Moving that to the other side, we've got twelfths going on again. 15 twelfths minus 10 twelfths, we've got a theta is equal to 5 pi over 12. We don't have to go any further because that is within our 0 to 2 pi. And then we've got our one going into the fourth quadrant, which is 7 pi over 4. So 5 pi over 6 is equal to 7 pi over 4. Moving that to the other side in exactly the same way we just did. That'll give us 21 pi over 12 minus 10 pi over 12, which is 11 pi over 12. And just like the previous part of this, we don't have to go any further because that is within our domain. For the last one, we've got cotangent, and I'm going to plus 3 to both sides and divide by 4. That gives us negative 1 is equal to cotangent theta plus 3 pi over 4. I don't deal well thinking in cotangent. I also know that cotangent of theta is equal to the reciprocal of tangent of theta. So I'm going to take the reciprocal of both sides. And tangent of theta plus 3 pi over 4 is the reciprocal. The reciprocal of negative 1 is negative 1. All right, so that means that we have the same side lengths, but opposite here. That's only going to happen with getting the same side lengths at these same 4 angles that we keep seeing pop up here. Because here we'd have root 2 over 2, root 2 over 2. That would be positive for tangent, so that one's not going to work. For the second quadrant, we got a negative root 2 over 2 and a root 2 over 2. For that value, that would give us a negative when we divide those. That one's cool. Third quadrant, we have a negative and a negative. That one doesn't work. And then fourth quadrant, we'd have a positive x and a negative y. That one works too. So we've got 3 pi over 4, and we've got 7 pi over 4 as our values here. Theta plus 3 pi over 4 is going to be 3 pi over 4. We end up getting 0 as our value for that, and that is within our domain. For the next one, we've got theta plus 3 pi over 4 is equal to 7 pi over 4. Theta is going to be 4 pi over 4, which is just equal to pi. All right, let's finish this up with looking at some logarithm stuff. So first of all, we've got log base 8 of 512. We got to figure out how to evaluate that. So that we know that's equal to some exponent, and I can convert between forms. We've got log of some base of an argument is equal to an exponent. That's the same thing as saying some kind of a base to an exponent is equal to the answer to an exponential equation. So in this case, we've got our base of 8, we've got our argument, and we're looking for our exponent. So let's figure out how this works. We've got some kind of 8 to an exponent is equal to 512. Okay, well I know 8 times 8 is 64. 8 times 8 times 8 is going to be 512. So that would be 8 to the 3 is 512, which tells us that log base 8 of 512 is equal to 3. We've got to use our properties of logarithms to expand the next one. So I'm going to kind of break this into some pieces here. I'm going to start off by saying this is going to be log of x squared plus log of y to the third, and then minus log of z to the eighth. The reason I'm going to do this way is that things that are on top of our fraction here are being multiplied together, and we know that exponents end up being added when we're multiplying their bases together, and that's what's really going on here. Logs are exponents. They follow exponent rules. When we divide things inside of a log, we end up subtracting those exponents. So that's what's going on with that minus z to the eighth at the end. And then we take those exponents and bring them down front of all three of these expressions. That gives us 2 log of x plus 3 log of y minus 8 log of z. At this point, we are done. For the next one, we've got to solve this equation. We're asked to provide both an exact and an approximate answer. I don't have a calculator in front of me that lets me do that well, so I'm just going to give you an exact answer, and you can calculate that on your own pretty easily. So the first thing I notice is that I already have my exponential thing by itself, so I'm going to convert this to log form. This is going to be log base 6 of my argument, which is going to be 10, is equal to my exponent, 3x. Finishing this up, we get log base 6 of 10 divided by 3 is equal to x, and that's our final answer. For number 12, we're going to go backwards here, and I'm going to start with log form. I've got my base, my argument, and my exponent. So this is going to be 7 to the 2 is equal to x plus 3. 49 is equal to x plus 3. Getting x by itself, we get 46 is equal to x.